Factoring quadratics. Okay. Now, we talked about the vertex form the other week, where we still had an A, if you guys remember, but we had an H and a K involved. This form, where we have three terms, is called the standard form. It's still a quadratic, so it still makes this parabola shape on a graph. Okay. And we have three variables, are A, B, and C. And we've just split them up so that we can refer to them as we go through the factoring process. Now today we're going to focus on variables where A is only 1. Okay? I'll show you two methods that work, whether A is 1, 2, -5, it doesn't matter, any other number. And then I'll show you a shortcut for when A is only 1. Okay? So we're going to start with today's method, and this one works for all of them. What you're going to do is I want you to find the factors of the very first term and the factors of the very last term. Okay? So let's think of 1x squared. Well, the only factors of 1 are 1 and 1. Okay? So I'm going to write them underneath in a column. 1x times 1x would give me 1x squared. Then I'm going to write the factors of the last term, 6. Well, we have 1 and 6, and we have 2 and 3. And I'm going to set them up in a column style. Okay? And then our middle term becomes very important here. And I'll show you the reason why. We're going to end up taking the products of these two columns, and they need to add up to our middle term, which is positive 5x. Okay? So, what we'll do is a little trial and error method to solve this. For instance, we're going to use, these will be our first terms when we go to factor. And let's actually talk about what it'll look like in our factored form before we go on. Our factored form will be two sets of brackets. So this is kind of the reverse of that distributive property of FOIL that we did before. Yesterday, common factoring, we were only taking out one term. Today, we're taking and separating two separate brackets. Okay? So this column here, that will represent the first terms in each bracket. And one of these two columns, we have to figure out which numbers we're going to use, are going to represent the second terms in these brackets. Okay? So we're going to use trial and error. 1x times 1 gives me 1x. 1x times 6 gives me 6x. When I add these products together, do I get 5x? No. Okay? Then I try going across. Is that going to give me any difference in this case? No. Okay? Later on, when a is a different value, that will give me a difference. But because it's not, it still didn't work. So we know that this column here is no good. It does not work for us. Okay? Which means, hopefully, the second column here is the one that works. 1x times 2 and 1x times 3, that'll give us 2x and 3x. Does that work? Yeah. Excellent. Okay? So 2x plus 3x does work. So that means we are using that column. Okay. Now, in this method, and I'll draw these arrows to help. When we go to put them in, we know these two are both going to be the first term. So I'm just going to put 1x and 1x. Now, this may seem a little confusing to start, but it's important for when we go on to later lessons. 1x times this 2, I have to put them in opposite brackets. Okay? Because I multiplied this 1x by this 2, they go into opposite brackets. So my positive 2 goes over here. And then this 1x times 3, they have to go into opposite brackets. So I put my positive 3 in the other bracket. Now, if you notice, it didn't actually make a difference because the first terms were identical. But again, when we get to a value of a that's not 1, that move or that motion will be very, very important. Okay, I'm definitely trying to pause it. So we've done one method. We're going to do the exact same question using a different method this time. Now in this method, what we're going to be doing is we're going to multiply the first and last terms by each other. So A multiplied by C, okay? And that's going to give us a value, and that value is going to be very important, okay? And then that value there we're going to be using. Okay? So what we're really going to be doing is we're going to be looking for two numbers. I'll put gray. A number multiplied by another number that is going to equal what A times C is. And then we're going to also look for that same number added to the other same number that are going to add up to our B value. Sounds confusing, but let's actually go through this. What is our A times C? That's going to give us 1 multiplied by 6. So what is A times C going to be? 6, okay? So I'm actually going to write it on this side. Is equal to 6, okay? And what is our B term? 5. Okay. So let's kind of take out what I have on the side here, because I think some of you guys have become lost. Okay? And this might be one of the easiest methods for you guys. Okay? So I want to focus on it like this. Don't worry about the letters on the side, just look at this now. Now that we multiply these two, that's the value, and we've added. We need to find two factors that are going to multiply to 6 and add to 5. Okay? We just had to find the 6 at the first part. That was it. So what two numbers we're going to use?
2 and 5.
2 and 3, right? We've already done this before, so we know those values will probably be 2 and 3. 2 and 3 will multiply 6 and add 5. Perfect. So now that we have that, we take that original question, f at x is equal to 1x squared plus 5x plus 6. Okay? And what we're going to do is this 5x is now going to be split. Okay? We're going to take these values, 2 and 3, and we're going to call them 2x and 3x. Okay? And essentially we know that if we add them together, they make 5x. So we're going to f at x is equal to 1x squared plus 2x plus 3x plus 6. Okay? Now this is where yesterday's work became important. We have to do our common factoring now. Now when we do our common factoring here, I want you to think of this as a set and this as a set. And we're going to common factor out of both of these brackets here. Now is there a common factor with 1x squared and 2x? What can I factor out? 1x, or just x, right? So we can factor out just x if we want. So we're going to be left with x multiplied by x plus 2. And what would be a common factor of 3x and 6? 3. We can take 3 out, right? So, and it's a positive 3 we're taking out, so plus 3 on the outside of the brackets. And what are we left with inside? X plus 2. Now, do you guys remember what would our common factor here be? X plus 2 is the common factor. It comes out. So now we get x plus 2. And what goes in the other bracket? X plus 3. And if you guys look, it's the exact same answer we got before. X plus 3, X plus 2, X plus 2, X plus 3. Different methods, same answer. Now we're going to go through the shortcut method. Remember, this is our A, our B, and our C. Now the shortcut method only works when A is 1. Because A is 1, if you guys remember we had to multiply A times C in that second method we did. Well, when A is 1, is that going to change the value of C? No. So all I'm going to be looking for is two numbers that multiply to the C value, which is 6, and two values that are going to add to the B value, which is 5. And what are those values? 2 and 3. Well, once I have them to be 2 and 3, and again, because A is 1, I can go right to the brackets. What are my first terms going to be? The only factors of 1 are 1 and 1. So we know they're going to be 1x and 1x. And the other two values are going to be exactly what these are. Positive 2 and positive 3. Extremely easy method because A is 1 in this case. If A is not 1, we cannot use this shortcut. It's no good. It will not work. You have to use one of the other two that we used before. Okay? So just so you can see them all, this is them in comparison to each other. Yeah, the one on the right only works when the A value is 1.